Hey there kids, welcome back. This is Module 3, Lesson 14. And in Lesson 14, there's just a ton of really important information. So I'm going to show you kind of a lot of notes. Pause the video as needed to keep up. But let me talk you through them, and I have a little poster that you can also write. But I want to get into the work so that you can do the strategizing. Everybody might think about it a little differently, so I want to show you kind of the best way to do it. Now, when we're strategizing, we're going to be using rules that we can apply in mathematics. And so some of the rules are in this order of operations poster that you can take a moment to copy. And this means that, math steps and things have to be done in this particular order. And in order to get the right answer, you might get an answer, but it might be wrong. And so we call this PEMDAS. And this is about how to solve math problems in the proper order when you have more than one operation, like plus and minus in the same string of numbers. So the order in which you would solve always would be whatever is in parentheses is first. If you have exponents in the problem, you would solve those second. But in 5th grade, we don't have a whole lot of these. This is very important to note that multiplication and division have pretty much the same power. Therefore, you solve left to right, just like you're reading. But they have more power, so therefore should be done first before you solve anything with addition and subtraction. Again, whichever the order is, going from left to right. So write that down, take a minute. I will refer to it when things need to be solved in a particular order. Back to the notes. Now, when you have all the numbers that you're putting together, they're called addends. You can move addends around in any order. And we've talked about this before. The commutative property of addition and multiplication means you can move them around and solve them in any order, and you'll still get the right answer. You can't do that with subtraction. So when we get down into the subtracting, that is totally not applicable, moving around. You have to only have this whole, okay, in this place. And then everything else, you really have to be very careful with the arrangement of the numbers. So when adding things, today we're going to talk about joining like terms. Shuffle them around so that you put the thirds together, the fifths together, and it will help you get simple answers. With subtraction, like for example here, if I start out with 5 7/8 and this is my whole, from that I would take away a half. I will also take away 7/8. I will also take away 1 1/2. The thing with today is that because this is all subtraction, I can take away something with a common denominator before I take away the others. And so that's going to be part of your strategizing. So look for things with common denominators. The next piece of strategy is that if you see something else that has common denominators, listen to the word and you're going to take all this away. It means that you can combine. The word and is kind of a key for addition. Now notice what I'm doing. I'm taking the half and the 1 1/2, and I have to remove all of this from the whole. So why not just combine it, take it away in one step, and that is also part of our strategizing. Okay? Next, we're going to have multiple operation signs within a whole string of activities. And so again, this is the whole, W-H-O-L-E. And so from this, we're going to have to take this away. However, I would then have to add this. Note that it has a common denominator with this. When I'm adding, why not add it first so that I can simplify, noting that 1/6 and 5/6 makes 6/6, which is 1. Combine that with the 2 to get 3. Then you can easily subtract 1/3 from a whole number. So that's what the strategy is today, is to try to make things easy create mental math problems so that it will be easier to solve. Another thing you're going to do today is they'll give you some improper fractions and perhaps even a decimal. Remember that with improper fractions, you can turn it into a mixed number. So it would be the top divided by the bottom, or how many of the bottom can you fit into the top. 3 could go into 14 4 times. That would give you 12, but there would be 2 left over. So this is 4 times with 2 left over. 4 2/3 would then be the mixed number that's equivalent to 14/3. 9/4 is equivalent to 2 1/4. If you combine your whole numbers and then get equivalent denominators, that's what we're going to do for those. Finally, the last one is if you have a whole that's missing, and from this whole you take away 15 and then you take away 4 1/2, and that leaves you with 7 3/5. The strategy would be to work your way back by putting all these things together in order to find out what you had at first. And again, using common denominators. And if they give you a decimal, watch out, because decimals, remember, have tenths, hundredths, and thousandths to the right of the decimal. And that is nothing more than putting a 10 or 100 or 1,000 as your denominator. So those are your notes. Oh man, that's a lot, right? And so today we have fun yellowish, or I guess we call it buff. This is buff paper. And so we're going to use this strategy of rearranging the terms so that you can add or subtract mentally, and then we're going to solve. So we're going to do what we can mentally so it will help our solving be easier. So first thing I want to do is I want to recognize that 1/4 and 7/4 would make 8/4. Now you do as much as you can mentally. 8/4 is actually equal to 2, okay? Now 2 2/3 plus 1/3, well, 2/3 plus 1/3, that's equal to 3/3, which is 1. And 1 plus 2 is equal to 3. So I end up with 2 plus 3 for 5. So again, rearrange things so that you can add or subtract mentally, and then combine what you can. You can write more if you want. If you want to rewrite it, you're certainly welcome to do that. Okay? And solve. And you want to put things in simplest terms if you can. Now let's take a look at this one. It's 2 3/5. Look for those denominators. Here I have fifths as well. So watch the sign, because this is a subtraction, but that goes with the 3/4. So what I'm going to do for my strategizing, okay, I'm going to leave this alone for right now, because I'm going to work with the 2 3/5. I'll write it so you can see what I'm doing, and the 2/5. These both have fifths. That makes 5/5. If I'm combining 2 and 5/5, I will get 3. Now, I would have this as part of my total, okay? But I have not done the subtraction yet. This whole section, the minus 3/4, has to be the next step. So 3 minus 3/4, you should know, what does it take to make 4/4? That would be the 1. And so we're going down from 3. Remember, if you use a number line, that'll show you you're going to end up with the 2 and 1/4 as your answer, okay? So use a number line to go down from 3 into the 2's, okay? Use the number line, and you're taking away 3/4. So it would go 1, 2, 3. Oops, that's a little off, but right there at 2 and 1/4. Okay, so strategize mentally to make this work easy. It looks crazy complicated, but it doesn't have to be that hard. Now this is one with all that subtraction. So what does all this equal? Well, what I want to do is I want to combine like terms and work it out. So I'm going to take my 4 3/7. You can write anything you need to. Notice that this is the whole, that everything is being taken away from. From this, I will eventually take away the 3/7. Look at how nice and easy that is. If I have 4 3/7 minus 3/7, that leaves me with 4. Now I've done this part. Okay, now I have to take away 3/4, and I also have to take away 2 1/4. So I'm going to focus on these two for a moment. I have to take away a total of 3/4 and 2 1/4. If I'm taking away a total of 3/4 and 2 1/4, I can combine this whole amount and take it all away from 4 in one step. So what is the total of this? If 3/4 and 1/4 makes 4/4, which is 1, and 2 and 1 make 3, then my answer should be 1. All this adds up to 3. Take it all away in one step to get 1. How do you like these? Mixed operations. Don't touch this one. Let's look at 5/6 and 1/6. That would make 6/6. So hard to say that. 6/6 or 1. And then if I have the 1 and 1/3, because I'm simply attaching that I would eventually add anyway, from that, I'm going to take away the 4/3. Now let's take a look at this 1 and 1/3. What is it really? Well, if it's thirds, it's 3/3 and 1/3. So that's really 4/3. Oh, yes, and sorry for the interruption, but we will ignore that and then write down our subtrahend 4/3 minus 4/3. And what do you end up with? You actually end up with 0. And we'll put that one in a box so it's not like a donut. Okay, so we have 4/3 minus 4/3. Now, for this one, we have to do something a little bit differently. We're not getting the total of all the numbers and using PEMDAS per se. We're going to look at what the order is and try to get what's missing. In this one, what's missing is the answer. So it's kind of like what we were doing before, but not this one. So if I start out with the whole that is 11 2/5, and I don't have any more fifths, what I can do is I can look at the denominator and combine like terms. Now this one has an improper fraction. That's okay. If I have 3 2/3 here, and I want to change this to find out how many 3/3 are there in 11/3. So 3 goes into 11 3 whole times, because that would be 9, with 2 left over. All of a sudden, we have our total amount here that I have the 3 2/3, and I have another 3 2/3. So all this is coming off of 11 2/5. So what do I have? I have two things that I am going to take away from this, and these look very similar. Now remember that with PEMDAS, you cannot do things out of order. You have to go left to right. So I know students will look at this and say, 3 2/3 minus 3 2/3 is 0. But I'm not taking 3 2/3 away from 3 2/3. I'm taking it away from 11 2/5. So the problem with what a lot of students will do is that they will not recognize that this is not necessarily going to be subtracted from here. It should be combined. So I'm going to take my 3 2/3 and 3 2/3, and I'm going to add them. Okay, so let's just take this right out right here, and I'm going to combine everything so that I can take it all away. Okay, so when I add this, I get 6 4/3. 4/3 is equal to 1 1/3, so that would be 7 1/3. That is the total that I need to take away from 11 2/5. So that might be confusing, but go back to the PEMDAS, the order of operations, and realize that you cannot subtract out of order. You have to go left to right. From here, if you realize that we have different denominators. I need to have 15ths as my denominator. If you wanted to solve this right away, you could simply do 6. Okay, so we know that that's eventually going to be 6, but let's get our common denominators and do our subtraction. 6 minus 5 is 1. Oops. My bad. 11 minus 7 is not 6. I was thinking of 13. Duh. Okay. Anyway, 4 and 1/15 is our final answer there. You guys are probably red flagging it going, hey, wait a minute, that's not the answer. Good thing I have you. Okay. It was like telepathy. You were communicating with me. Let's go on to B. We have 11 and 7/8 and 3 and a 5th, different denominators, so we're going to have to get a common denominator in order to combine. Then from this is going to create a new whole. We would subtract something to get 15. So let's take our numbers that we do know, 11 and 3, and get 14, okay? Then we're going to get a common denominator for only the fractions here. So let's focus on this for a minute. Between 8 and 5, the only thing I can get is 40. So let's use 40ths. 5 times 7 is 35. I'm multiplying because my opposite denominator is the number I need. 35 plus 8, we'll see if I can do that correctly, is 43 40ths. Still have 14, don't forget about it. This is actually 1 and 3/40ths. And so I would have 15 and 3/40ths. Now that's what I have as my new whole, 15 and 3/40ths. From that, I'm going to take something away, and I get 15. So your strategy is to think about, well, what would I be taking away? Oops. I would be taking away the fraction in order to be left with the whole. So 3/40ths is the number that is missing here in the subtraction problem. So if you think about what you're doing as you're going through and adding and subtracting and in what order, caution, caution, watch the order. It can help you to not have to do quite as much work. Let's keep on keeping on. 5/12 is our whole, and from that we have to subtract something. Then after you subtract, you would have an addition problem, which this is actually equal to 1 and 1/4. And from here, you're going to end up with 2/3. Now, part of this, the reason this can be confusing, is because the equal sign is a balance. Okay? So whatever is on the left, all this has to equal 2/3 when I'm combining things and taking things away. So let's take a look at this problem with common denominators so it's a little bit more helpful to see everything. Look at 12, 4, and 3. They can all be 12ths. At least we'll see everything in like terms or common terms. So I want everything to be 12ths. And I'm going to ignore that call because I am very busy. So if everything is 12ths, then I'm going to have 1 and some 12ths and some 12ths here. So 3 to get to 12 is times 4. 4 times 2 is 8. 4 to get to 12 is times 3. 3 times 1 is 3. At least now they have common terms. Okay? So from 5/12 I have to take something away. Then I'm going to add, and if you want to make this an improper fraction just so that everything is the same, you could call it 15/12. And then I'm going to end up with 8/12. So because I'm going to have this and addition sign, this, I can combine this and this, okay? This is going to be added to this eventually. why not start now? So take your 15 twelfths. Okay, so I have 5 twelfths and let's do 15 twelfths. Okay. From this, I will still take something away to get the 8 twelfths. So what do I have? I have 20 twelfths minus something equals 8 twelfths. And now, do you see it? So we're trying to find the difference. And between here and here, we would take away something or find the difference between 20 and 8, and so I would get 12 twelfths. Okay, so when you start to see, okay, how to find the difference between different numbers, it can help you, or if you want to, instead of writing 12 twelfths, you could put 1. Either one is fine. Okay, so by breaking down and combining like terms and making things look a way that is helpful, it can help you see the differences between numbers. Now here's one of the ones that is similar to what we had in the warm-up. Starting with a whole, taking a bunch of things away, and ending up with this one. This is simply a work your way back toward the whole by adding everything up that is on this side so that we can create the whole again. So if I change and have 30 plus 7 1/4 plus 21 2/3, I can combine my whole numbers. So if I had 30 plus 21, I'd have 51, and 51 plus 7 is 58. Now I can just focus on the fractions. Okay, I need a common denominator, and again, don't forget about your 58. That's a big difference. And we have 12. This is my opposite scale factor, so 3 times 1 is 3, 4 times 2 is 8. And I have 58 and 11 twelfths. That one seems a lot easier than this one because we're just going one direction. This one you kind of have to skip around and think a little bit. When it's all addition, that's also kind of easy. If they give you improper fractions, just flip it around into a mixed number if you want to make things easier to work with. 5 goes into 24 4 whole times with 4 left over. Missing add end. 7 goes into 8 one time with 1 left over. Now that I know what to combine, 4 plus 1 is 5. And then I can just deal with the fractions here. Oops, and I forgot my other add end. Oh, and there go the light. Woo! It's a great day. It's a great day here. Let's just move this over. Plus a missing add end equals 9. There we go. Make a common denominator. 35 is it. This is my other scale factor. 7 times 4 is 28. 5 times 1 is 5. Plus mystery number equals 9. 33. 5 and 33 35ths. Plus mystery number equals 9. So since I need to find the difference between these two, I'm actually going to take this line out of the way and we'll move that over. I have to do a subtraction problem. Now, not too hard, you know how to do this. Okay, if I have 9 minus 5, I have 4. But I still have to take away the 33 35ths. That's okay, you know how to do that. Remember, you're going to go down to the next one, make up the difference, and put your denominator. And that's how you solve that subtraction. Okay? Next one, we're really getting close to the end here. When they give you decimals, remember I said don't be confused. Just make it a fraction if that helps you feel comfortable. 11 and 1/10 plus 3 and 1/10. You have to then subtract a mystery number. Now, you can't move that around. And then let's make this a proper fraction. 10 goes into 99 9 times with 9 left over. Now that it looks a little bit better, we can look at it. It's all tenths. So this should be not too bad. So you can combine these terms here, 11, 12, 13, 14, and 2/10, okay, would be our, our addend right here, because we're combining addend plus addend. Then we have to subtract something to get 9 9/10. So I need the difference between these two, and they're all tenths again. So I need to find the difference between these two in the best way possible. 14 minus 9 is what? So if you write it out this way, so we're just kind of shuffling this for a moment. 14 minus 9 is 5, but I can't do, this is one of those ones where you cannot take the 9/10 from 2/10. It's too big. So you can take all of this from the 5. So if I have 5 minus 9/10, you can put it back with the 2/10. So I'm going to put back the 2/10 in just a moment. Don't forget about it. What's 5 minus 9/10? Okay, remember how to do that. We just did it right up here, or right here. So you would go to 4 and 1/10. Now I'm going to combine that. So it's going to be 4 and 3/10, and that is the difference between 14 and 2/10 and 9 and 9/10. Okay, 4 and 3/10. All right, now how are we doing on time? Ooh, we got to hurry up. D'Angelo needs 100 pounds of garden soil to landscape a building. In the company's storage area, he finds 2 cases holding 24 3/4 pounds of garden soil each, and a third case holding 19 3/8 pounds. How much gardening soil does he still need in order to do the job? He's got 2 of 24 3/4. So make a little tape diagram, 24 3/4 again. He has a third case with 19 3/8. How much gardening soil does he need in order to do the job? And the job requires 100 pounds. So for this one, we have to combine like terms again. So I've got 48, easy addition, and 6/4. 6/4 is improper. That's actually equal to 1 2/4. So don't forget about adding that. Now I'd have 49 2/4. Just leave it like that for now. Plus 19 3/8. Now I want to change this to have eighths. So I'm going to leave that alone and make eighths. I have to multiply by a scale factor of 2, so I get 4. Now I can combine all my terms to see what I have. So 49 and 19, if you need to add on the side because you're carrying and regrouping, do that. Get your 68 and 7/8. That's what he has. But the total is 100. And I need to find the difference. So what's 100 minus 68? So you could do it in a couple ways. If you use 70 and round, that would be 30, but it's 2 more, so it'd be 32. So 100 minus 68 is 32, but you still have to take away 7/8 more. So you would end up with 31 1/8 pounds needed. I hope you guys click subscribe and come back if you're not already in my class. And the last problem, let's hope I can finish it. Volunteers helped clean up 8 2/10 kilograms of trash